Hi, in this video I test the 74LS04 inverter that I believe to have damaged in the previous video. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. So let's get into this testing here. In the previous video I had this line here, which is an output line on the 74LS04 inverter, tied high, which means that I was basically bleeding current directly into that line. I think I hurt this IC as a result of doing that. So what I want to do is I want to hook it up and do some testing and see if it will invert for me properly. This video is likely to be short. I haven't done any testing on it yet, and one of two results are going to happen. Either I'm going to confirm that everything is good, or I am going to have some sense of loss of faith in this particular IC, and it's going to end up in the trash. So I have a pin here, and I'm going to stick this pin in the ground just to make it easier for me to use my voltmeter to test. And I will zoom in a little bit here so make it a little easier to see what it is that I'm actually working on here. All right, so this pin is hooked up. This pin is hooked up to ground. And what I want to do is I actually want to hook this pin up to this output so that I can take a look at the particular pin in question I had directly wired to power. And then I want to create a signal that I can then invert. So I want, on that particular inverter, it's a 6 inverter. On that particular inverter, I want to bring it high. My expectation is that this will be reporting a value that is very close to 0 volts. So I believe specification is 0.8 or so. So let's see here. Oh, let me pull my voltmeter in here. Turn it on. That helps. Let me untangle. I apologize for doing this off screen. So, ground here, and so connected to high. The inverter is that's all over the place. The inverter is connected high, or is pulled high, and I am getting 4.3 volts output. That should be reporting something closer or more reasonable to 0. If I switch it to a low input, the output should be much closer to 5 volts than it is. But if I go to a low input, or I'm sorry, a high input where the output should be low, I'm still getting 4.3 volts. So this IC is destined for the trash. While I'm at it, what I'm going to do, since it's a very short video, I'm going to clean up these power wires here off to the side, and I'm going to cut a couple, these power wires, I'm going to cut a couple to put in their place, and take out the temporary wires there. Okay, that's done. And then a quick test with power. And I have not hurt the timer circuit. I'm going to pull out these pins. These pins will save for a different occasion. Pull out this IC because I do not want to leave it in here and forget that it's bad. So that's in the trash now. Before I go, I created this label indicating that this is a 556 timer chip. And I'm going to apply this to the top of the IC here just to make sure, A, that I don't forget what it is and end up wiring it up wrong again, and B, to hopefully make it a little bit more visible to you on camera. So let me get that done. Okay, let's hope that stays. Thank you for watching. In the next video, I will work on getting the single step button wired up. I promised that last time, but I wanted to make sure before I went down that path that I didn't have a problem with that inverter, and of course I did. And then I also need to include the power supervisor module, which I worked on in the first and second videos. I want to get those integrated to this circuit as well. Thank you. We'll see you next time.